Good afternoon, everyone. I'm Tom McKay. I'm a staff systems engineer with VMware, and get the great privilege to introduce a couple of guys I've been working with the last couple of years. One is my customer, Chris Haker, principal architect for Reed Elsevier. For those who don't know, Reed is a global publishing and information company, has a number of business units. One you may know of as LexisNexis, etc. And then also Jeff Sastek, who is a Tier 1 application specialist. Worked with Jeff for a number of years. And so today, Chris is going to be our principal presenter on how their company Virtualized Exchange 2010. So this is going to be an interactive session, so we expect lots of questions. And I'll turn it over to Chris.
Thank you very much, Tom.
Thanks, Tom.
Good afternoon. Thanks for coming. This is How a Global Enterprise Virtualized Exchange 2010. As Tom said, I'm Chris Haker. This is my partner, Jeff Sastek from VMware. We would ask you to hold questions till the end of the presentation, so that way we make sure we get through our whole deck. We'll hope to leave some time at the end for questions, and then we'll have at it and have a good discussion. So the standard disclaimers.
Next.
Exactly. I hadn't read through them anyway, so I can't even present to them. So this is the agenda that we're going to follow for the presentation. I'm going to give you a short background on Reed Elsevier and our environment, how things looked when we were running Exchange 2003 before we decided to migrate, kind of some of our decision data points on why we decided virtualization for Exchange 2010, how we did it, some of the best practices, recommended practices, lessons learned that we gained through that migration. Then I'm going to turn it back over to Jeff. He's going to give you some data on vSphere 5 and how that works better for Exchange 2010. Then we'll come back and we'll look at the environment 16 months later, some other things that we learned and where we're at now, and finally wrap it up with some value delivered to the business through virtualization in Exchange 2010. So Reed Elsevier, like Tom briefly said, we are a global company made up of 4 business units. LexisNexis is legal, search, and information. Elsevier is science and health technology. Reed Business Information is publishing, magazines, periodicals, and digital online content. And Reed Exhibitions is conference and exhibition planning and execution. Our company, prior to 3 years ago, was a distributed IT. So each business unit ran its own IT. And about 3 years ago, we decided to centralize that function. What we wanted to do was save money, gain efficiencies by bringing that all into one group and avoid duplication and a lot of the things that go with having all that IT spread out across the business units. Our company culture as a whole was kind of slow and steady, so we didn't adopt new technology very quickly. We took a long time to evaluate things, and that was kind of our general way of approaching new technologies and upgrades. As we moved to a central IT function, however, though, we kind of ramped that velocity up a little bit and stepped up our cadence so that we adopted new technologies a little bit quicker and took into account, can we adopt this or can we adopt that without waiting to see it in the marketplace for a few years. So our pre-migration environment. We were on Exchange 2003, and we have a global presence. So we had 102 physical servers spread over 12 countries. With over 32 Exchange administrators in some fashion. Now, not all of those people were full-time Exchange administrators, but it was more of everybody does a little bit of Exchange administration as part of their overall IT role. So we had that administration spread out, very inefficient, a lot of duplicated effort in the business units. A lot of our data centers were at capacity or nearing capacity. So adding, as we approached this migration, one of the thoughts was, do we want to add more physical servers to our data centers that are already crowded? And of course, virtualization lets you avoid a lot of that. And then the other big issue was our business units, when our IT was decentralized and handled by the business units, every business unit has its own agenda, right? They've got their own priorities. They want to upgrade when it's, they have the budget for it or when it's an issue for them. And it was a lot harder to drive the upgrade of that environment across every business unit because Exchange is one of those applications that's shared by everybody. Okay, you've got one Active Directory, one Exchange installation. Not everybody has their own forest with their own version of Exchange. So, sorry, before I get into that, real quickly in the room, how many people are on Exchange 2003 or Exchange 2007 right now? Wow. Okay. And how many people are considering an upgrade to 2010? And finally, how many people are attending this because they want to virtualize Exchange 2010? Excellent.
How many
have already done it? Another good question.
2010.
Virtualized Exchange 2010?
Of those that have done it, 2010, all the roles virtualized, including the mailbox. Even 2007? Great. Thanks.
Excellent. Thank you. So this is kind of a view of our environment when we were running Exchange 2003. And just as another data point, we skipped over 2007. So we were still running 2003. And when Exchange 2010 was in beta and we kind of got hooked into that, we decided it didn't even make sense to mess with 2007 and jumped right over that. So highly distributed, lots of physical servers, lots of duplication of effort, hardware, cost, lots of complexity. After the migration, we had to boil down to 4 locations, centralized, completely virtualized. So some of the decisions around why we decided to virtualize, kind of like tipping points for virtualization. The first one is, like I talked about, our data centers were all nearing capacity. And so we don't want to go adding a lot of physicals in there. So even if you do, you're going to be replacing some of the physicals that you're running 2003 on because they're end of life. You're going to still have to stand up the new physicals, and all that stuff's going to have to migrate to, and you're going to have twice as many servers for a certain amount of time. Cost savings in the data center and the hardware. Obviously, less physical hardware is less spend. If you can buy 2 or 3 hosts and put 20 or 30 Exchange servers on them, then you're saving a lot of money over physicals. We also decided to centralize. So with Exchange 2010, there were a lot of features in there that led us to centralizing and putting everything in one place in a set of data centers and reducing our administrative headcount. We've got high availability, DR resiliency, and flexibility with the virtualization as well, as opposed to running physicals. So you can move them around easily using HA or DR or vMotion. And experience with virtualization. As a company, we had been using virtualization for a long time. About 65% of our infrastructure is already virtualized. So we felt really comfortable with virtualization as a whole. Now, we'd never virtualized Exchange before, and that was a risk, though, that we were willing to take based on our experience with virtualization and other products.
So, Chris, before we go to the next slide, you mentioned centralization and admin reduction. So did you actually, when you say admin reduction, did you actually let people go, or did they move into new roles?
That's a great question. So no, I don't mean let's get rid of all of our administrators, but when a lot of these administrative roles are within the business units or even within the centralized IT, you can take them off of doing a lot of those commodity tasks that Exchange requires and kind of repurpose them and have them point towards things that are better, that add more value to your business, as opposed to just administering Exchange.
So what you're saying is we took these people that were running around replacing HBAs and NICs and servers in the field and put them into roles in which they were adding value back to the business.
Exactly. So some design decisions when we started to approach this, scale up or scale out. And what I mean by that is, and this is subjective, so I don't mean to say that it's night and day, one or the other. It kind of goes with the philosophy that your business has or your IT people have. Do you want to put 14,000 mailboxes on one virtual mailbox server, or do you want to have 10 mailbox servers with 1,100 mailboxes each? There's pros and cons for both. And I'm not going to try to sell you on one decision or the other, but tell you what we decided on, and that was to scale out. Okay, so we saw that there'd be more flexibility with more mailbox servers, less of the all our eggs in one basket approach. If you have one big Exchange server with 14,000 mailboxes and it goes down, even with vMotion or HA, there's going to be an amount of downtime there associated with that. Smaller mailbox servers allowed us to be more flexible, move them to different places as we needed to move that workload, as we did maintenance, patching, things of that nature. And if a server goes down, you're impacting a lot less mailboxes. Direct attach storage versus SAN. So we've got a large SAN infrastructure as a large enterprise. We're very comfortable with SAN. That was an easy one for us because we've had a lot of experience with it, and we know the features and the benefits of it. So with Exchange 2010, Microsoft drove the IOPS requirement by 70% down over Exchange 2003. And so there's a lot of literature out there about just use direct attach storage. Put a bunch of JBOD, attach it to a server, and that will give you all the IOPS that you need to run Exchange 2010 mailboxes on, and that's correct. But with the SAN, you get a lot more flexibility for downtime, for expanding volumes, for adding storage, things of that nature, and that's why we decided to go with SAN.
So, Chris, when you say expanding volumes, can you go into that a little bit, or maybe any personal experiences that you had
Absolutely.
Around direct attached storage.
Mm-hmm. So we've had situations where we've had NTFS corruption on a volume. It's brought the entire volume down. With a SAN and with virtualization, it was very easy to just go in there and add another raw disk mapping in there, move that data over, and bring the disk back up.
So, Chris, another thing that we often hear is, well, I can just add another server. Any thoughts on that?
Yeah.
How does that affect your DAG architecture, for example?
Right. So if you run out of storage in a direct attached environment, you need to either add another frame to that server or add another server to your environment to get more physical slots to put those disks into to expand your storage. Okay, and then you're striping or extending volumes and doing a lot of other things to get that extra space. You have to add more copies to your DAG. You need another Exchange license for that server. You have to provision that server. It's usually not a quick turnaround. Whereas when you have a SAN and with virtualization, you can turn around a new disk onto the server within a matter of minutes. So it's a really big benefit. Exchange is not virtualization aware, and by that I mean Microsoft's recommendation with regards to Exchange and virtualization is treat it like you're putting it in a physical environment. You don't do anything special with the design. You don't do anything special with the disk architecture because you're putting it in a virtualized environment. There's that 5% overhead with virtualization, and we found, at least in our environment, that we don't even notice that. We see no overhead difference between our physical environment, what we did in the lab, and what we have in production. So how we did it. We boiled this down to 4 data centers, like I showed you in the previous example. 2 in the United States, 2 in Oxford over in the United Kingdom. And we have data center pairs. So we have these 2 regional data centers that are about 40 miles apart. They're far enough apart that they're not on the same threat plane. So a flood, a tornado, something like that, short of a nuclear disaster, is going to take out both data centers. But they're close enough that we have high-speed connections between them both. Within each of those data centers, we run 3 hosts. Okay? We've got Dell R910s in there as our hosts. And we have 3 of those in each of the data centers for 12 physical servers in total. So we went from 102 physicals previously down to 12 physicals. With those hosts, we have enough capacity for failover within the data center and to another data center. So for instance, if one host goes down within one data center, we've got enough spare capacity on those 2 remaining hosts to fail those virtual machines over to it. Worst case scenario, you have a site disaster and that whole entire site goes down. We could fail all those hosts over to the other data center and run at about 25% reduced performance, which we decided as a company is acceptable. If you have a site disaster of that nature, running under a little bit of a performance load for a little while is acceptable to us. And again, those are those things that each business needs to decide for themselves. Everybody's got a different appetite for risk and a different appetite for what happens in the event of a disaster. And all of our hosts are SAN-backed. We went with 1 terabyte 7K SATA disks. So we have the virtuals balanced across hosts per role. And what I mean by that is you need to take care when you have your hosts, and most environments are going to have more than one host, that you spread your roles, your Exchange roles, your client access server, your hub transport server, and your mailbox server across your hosts. So that if one host goes down, you're not eliminating one of those roles. You know, if you have all your CAS virtuals on one host, or all your hub transport, or all your mailbox, and something happens to that host, you're losing a critical part of that infrastructure. So you want to make sure you've got them spread out. We have our DRS set to 1, so we wanted that at the most conservative level. We spread our hosts out, or spread our roles out amongst our hosts, and they'll stay there unless something catastrophic happens. We tested vMotion within the data center. We did this prior to Service Pack 1, so we're not at Service Pack 1 yet, which is the recommended level by Microsoft in order to use vMotion. But we've tested it successfully before that, and then, of course, it'll be supported once we move to Service Pack 1. We don't use any reservations at this point, so memory or CPU reservations, we haven't found a need for it yet. Right now, we're pretty comfortable on our processing and memory overhead within a host that we haven't had to worry about it. No contention. And we run a dedicated farm. So we've got farms across our enterprise for web server roles, SQL servers, all different application server roles, and they all live on one big farm. For Exchange, we decided to run a dedicated farm, kind of from a budgetary purpose and from a ensuring enough resources viewpoint. So again, this was the first time we had worked with Virtualized and Exchange, and we wanted to make sure that we would have the set and dedicated amount of resources necessary within that farm to kind of serve our messaging ecosystem. So BlackBerry Enterprise servers, which we also virtualize, Exchange servers, things of that nature. So this is what we look like post-migration, and I apologize, it's a bit of an eye chart. I struggled with putting too little or too much information in this picture, but when you get the decks after the conference, you'll be able to look at it a little bit clearer. But really what this just shows is our 2 data centers, ingress from the internet, and then we've got our regional data centers at the bottom. We replicate the DAGs between them. And that's just basically how we have it set up right now at a high level. So going through the different roles and kind of how we have them sized. For the CAS server role, we've got 4 virtual CPUs, 8 gigs of memory, 2 NICs, 1 for the enterprise and 1 for the backup. So we run all of our backup traffic on a separate network. We do VMDK for all of our disks, and we've got 2 different kinds of CAS arrays in each site. So at the primary site, we've got our internet-facing CAS array where all our external traffic comes in for Outlook web access, Exchange Active Sync for mobile devices, things of that nature. And then our other 2 sites are non-internet facing. So we've got CAS arrays in there that will get proxied through the internet-facing sites. And we employ hardware network load balancing, F5, big IP, that kind of thing, instead of the Microsoft network load balancing. Hub role, 2 virtual CPUs, 4 gigs of memory, same thing on the NICs. VMDK again for all disks, and we run Forefront for our antivirus. That's another interesting kind of data point, too. When you run Forefront for antivirus, you're supposed to have to increase your RAM and CPU for that slightly, and we've not had to do that yet. So we kind of kept an eye on them, and we're still running at the same configuration and able to take that load in. And then the Mailbox server role. So we started out with 1,000 mailboxes on each server, and we sized CPU and memory for that. Okay, so 6 virtual CPUs and 36 gigs of memory, and that was from the Microsoft calculator. And I don't remember it off the top of my head, but it was around 12 megabytes per mailbox plus overhead for the server. But since we've increased our mailboxes per server, we've not had to go back and add more capacity. So that flexibility and virtualization to stretch CPU and memory have really been beneficial. We run 3 NICs on the mailbox server, so we've got the client traffic on the MAPI network, backup traffic on the backup network, and then the separate network for the replication traffic for your DAGs. VMDK disks for our OS and our page file, and then we do raw data mapping disks for our logs, log files, and our database files. We're using 1 terabyte LUN sizes for the database disks and 500 gigabyte LUN sizes for the log files. Another data point here that we missed, when we formatted our data stores, we did not format them at the 8 megabyte block size, and so as we added more and more 1 terabyte RDMs for the databases and the log files, we got blocked. And eventually had to go back and reformat them and move things around until we got all of our data stores redone. So if you formatted them with 2 or 4 megabyte block sizes, you'll run into that at some point if you're using 1 terabyte LUNs.
So Chris, one of the things you have on there is virtual CPUs. Have you found that you've had to add additional virtual CPUs to running Exchange servers? And how has Exchange reacted to that?
We have added CPUs to the Mailbox role. We started out with 4 virtual CPUs. So Exchange has handled this really well, and this is another benefit of virtualization. You could start out small. You know, in a physical environment, the server ships with the memory and the CPUs that it ships with. And it's pretty easy to add memory, although it takes time unless you have the spare memory on hand. Adding CPUs, of course, is a lot harder if you can do it at all. With virtualization, you could start out small. Start out with 2 CPUs and 4 gigs of RAM or whatever you think might be a minimum. And if you find out that you're resource constrained, raise it, okay, and retest it. And it's great for this kind of environment because you don't want to use more than you have to. Okay, and in a physical environment, you might say, well, I'm going to plan for worst case scenario and order 8 cores when you might only need 4 or whatever. And then you end up spending too much money. And then at the end of the day, somebody from monitoring comes to you and says, you know, all your Exchange servers, you spent this much money, but all your CPUs are running at 30%. You're really underutilizing this hardware. With a virtual environment, you can up it and down it as you need it. And, you know, we went with a dedicated farm, but in another environment, if you don't do that, you could throw more workload on there. And just, you know, if you find out you're underutilized, throw more workload on there and give it to somebody else to take. So with adding CPUs, as long as you're not crossing that boundary where you have to change your hardware abstraction layer under Windows because you've added, I forget what the breakpoint is, from 6 to 8 CPUs or whatever it is. It's a reboot, and it's easy, and you test it, and that way it's a lot easier to find out where that kind of like that watermark, that high watermark is for what you need from a resource perspective. So SAN configuration. We're running EMC Clarion CX4, again with 1 terabyte, 72 RPM SATA disks. We configured our disks in RAID 6 sets, and now all of our data stores are formatted in the 8 megabyte block size. Thank you. We're going to hold our questions for the end, just so we make sure we get through the deck, but we'll have plenty of time at the end for question and answer. So our LUNs are presented as 500 gigabyte, 1 terabyte logs, databases, OS, page file, miscellaneous storage, or VMDK. So I'm going to turn it over to Jeff for this slide.
Sure. So this is a VMware load gen test for those Exchange admins in the room. This is a test after you've installed Exchange to validate, will your Exchange workload be able to handle, right? So as we're looking at this chart, on the left-hand side, you'll see counters, right? For the Exchange admins in the room, or when you're working with the Exchange admin, these are the metrics that make their phone ring, right? When they exceed what we list on the right-hand side in terms of criteria, right, that's when you have a performance problem. So what we did is we tested this with 500, right, physical versus virtual. That's what the column P500 versus V500. So these are mailbox sizes. So this is a mailbox of 500 users, a VM running 1,000 users, and a VM running 2,000 mailboxes. And as you can see, even under the virtual 2,000 users, they are all well within the Microsoft criteria, which is listed on the far right-hand side. So what this is here is to explain is that if you properly architect and implement an Exchange implementation, you can get extremely good performance. Right? So Chris, this is a VMware study. This is a load gen study. How does this load gen study compare to what you at Reed Elsevier see in your production environment?
And it compares very favorably. When we tested this out in the lab, we saw just like this, a very small threshold between physical and virtual, and that the virtual environment would handle Exchange 2010 very well. So this very closely mirrors what we see today.
Do you have any data on that?
Maybe. So this is CPU performance across a host, running 2 CAS servers, 2 hub servers, and 3 mailbox servers over a 24-hour period. And you can see that Exchange is not CPU bound at all. It's a much more memory-intensive application. We've got a very typical CPU profile here. Down overnight, spikes up at 8 to 9 a.m. when everybody comes in the office and fires up email. Spikes again at 5 p.m. on the far left there when everybody's leaving for the day. They're doing one last run through their mailbox. And then you get a tiny little spike in the middle where we're running backups. So a very typical CPU profile. And you can see that the utilization is very low for our hosts, so we've got plenty of capacity on there for CPU. From a disk I/O perspective, same thing. Very even, very low. You've got that one spike in the middle there where backups are running. And that's where you get most of the disk latency in our profile.
So that is from your production environment,
yes.
Those 2 slides, correct, Chris?
Yes, that's from our production environment. You got it. So lessons learned. Let's start off with backups, because this is something that we didn't see in the lab. And this is where the lab is very important, but it's also very important for the lab to mimic production as best as possible. We decided initially to go with native Windows backup to back up our Exchange 2010 environment. Once you install Exchange, Windows backup is Exchange aware, and it'll back up your databases. In a DAG environment, however, it will only back up against your active databases. You cannot point it to a passive database and get a successful backup. So when we started out, normal performance, backups are running great, overnight, 8 hours, no issues. All of a sudden, we start seeing disk contention. Clients are dropping their connections to the databases. The disk queues are going up. We can't figure out what's going on. And we finally find out that as the mailbox sizes grew and the database sizes grew 6 to 8 months into the migration, backups were starting to spill over into the 8 a.m. period when everybody would come in and log on to the network. So with those disks, the active users coming into the database with Outlook MAPI connections, and the Windows backup software hitting the disk to back up the active database through the disk into contention. So how do we fix that? We decided to move away from Windows Backup to Microsoft Data Protection Manager. Now, the good point here is this software is relatively inexpensive, and I hate to sound like a commercial, but it was great. And it allows you to hit the passive instance of your DAG to back up your database and do it in a way that you can recover from it. So we were able to take that backup software, run it at the same time, but point it at all of our passive databases instead of our active ones, completely eliminating that contention issue. Backups run very quick. Active users aren't impacted, and it was a real win for us from a data retention standpoint. FreeBSD was another big issue that we ran into in this migration, and because FreeBSD, as I found out, unless you spend a lot of time deep in the weeds with FreeBSD, it can seem very complex. So across 3 different client platforms, Outlook 2003, Outlook 2007, and Outlook 2010, and then Exchange 2003, Exchange 2010, we ran into a lot of FreeBSD issues. You've got executives being migrated over, but their administrative assistants are still on 2003. Or they've got multiple administrative assistants, and one was on 2010 and one was on 2003. So all of those combinations, plus some hot fixes that hadn't come out yet, things of that nature, led us to a lot of FreeBSD issues. Something to take a good look at if you're considering a migration. Importance of the lab. So I can't stress that enough. And you hear it all the time, but some people say, it's an upgrade. I know everything about Exchange. We can skip the lab. But from this perspective, and especially if you're considering virtualization, that's something that you want to spend a lot of time on to make sure the disk that you decide to use, if you're going to go off a tier 1 disk and go to something a little bit cheaper, tier 2, tier 3 disk to take advantage of those cost savings, you want to make sure you validate that. You want to do jet stress. You want to do load gen and make sure that you're going to get the IOPS that you need in the lab out of your storage. You also want to replicate in the lab a lot of those kind of things that are unique to your environment, if possible, so that you get to test against them in the lab before you go into production. Gaps in migrations. And what I mean by that is when you go to migrate your users over, and this assumes that you're going to be migrating thousands of users or tens of thousands of users. Our environment is 35,000 users, and we've got about 60,000 mailboxes. So half are actual people, and the other half are conference rooms, applications, shared mailboxes, all that kind of creep that you get over 9, 10 years of running Exchange. But as you're migrating your users, migrate 1,000 people or migrate 2,000 people and wait. Let it sit, because stuff will pop up that you weren't expecting. And if you've migrated 1,000 people on Tuesday and then you migrate 1,000 people on Wednesday and 1,000 people on Thursday, you don't always see that stuff. And now you've got 3,000 people that could potentially be impacted on a new platform. And you're looking at either dealing with that impact, you have to have some kind of coping strategy in place or a workaround or a kludge or a Band-Aid to get those people the functionality that they don't have anymore, or you got to roll them back. So migrate some people and let it sit for a week or 2 weeks and make sure everything is smooth, none of those gremlins pop up. And again, all 3 of these bullets go hand in hand. Thorough due diligence, same thing. Talk to everybody, talk to all parts of the business. Do you have 1,000 users in this office that depend on this network copier that isn't compatible with Exchange 2010, and when you migrate them, they're ready to burn your office because now they can't use their network copier, or they don't have laptops, they're dependent on OWA with a token, and now it doesn't work because of something that you did. So just do your really good due diligence, talk to everybody, make sure you got every base covered as best possible. Database sizes need to be manageable. So this goes hand in hand with backup and recovery disasters. Multiple databases, smaller sizes, quicker to back up, easier to recover. Just everybody probably knows that, but it's worth pointing out. And host HA can interfere with the Exchange roles. So like I mentioned before, plan your roles across your hosts so that if a host goes down, you're not taking out a whole tier in your Exchange roles. You're not taking out all your hub transport servers, all your CAS servers.
So Chris, with that, I understand we're at VMworld, and this is a VMware conference, but of all the lessons learned, I'm not seeing anything related to the virtualized platform up there. And in the interest of full disclosure, what's been the problems with the virtualized platform that you've had?
Honestly, we have not had good setup. We've not had any big problems with the virtualization platform. And really, the biggest problem we had was the formatting of the data stores, and that was our problem because we missed that when we did our research. From a virtualization perspective, it has been extremely smooth. Very pleased with it. So I'm going to turn it over to Jeff now. He's going to talk about vSphere 5 and some of the things that come in that help out with Exchange 2010.
So I'm going to make this pretty quick because we're all here to listen to Chris and Chris's experience and learn from Chris. A lot of the stuff I'm going to talk about is in white papers or soon to be, as of today released or tomorrow released white papers. So vSphere 5, right? One of the things that we often hear when we talk to customers about Exchange virtualization is, well, in the physical world, I can do 8. I can get more mailboxes on an 8-way, right? Or I'm sorry, 12. Physical Exchange server will support up to 12 CPUs, right? 2 by 6, right? You can have 2 sockets with 6 cores. Well, in vSphere, you guys only support 8, right? In the physical world, I get more mailboxes, right? With vSphere 5 being released, that no longer applies, right? We can do the mailbox maximum of 12 virtual CPUs. In addition, you can even look at doing these combined roles, right? Microsoft will support up to 24 virtual CPUs if you want to combine CAS, hub, transport, and mailbox, right? So when you're looking at your architectures now, you have a lot more options with vSphere 5. Here's some great performance data. This is one of the hot off the presses, you're at VMworld, so you get to see it first type of slides. And this is performance data. And this is where we took an Exchange 2010 on vSphere 4 versus Exchange 2010 on vSphere 5 and said, did we do any better? And the answer is yes. And you can see for 8,000 mailboxes, that 8,000 mailboxes running on vSphere 4 versus 8,000 mailboxes running on vSphere 5, we improved performance by 13%. Right? And that 12-way, right, running a 12-way mailbox server, which is the maximum, as long as you're within that 500 millisecond threshold, Microsoft says you're okay. We came in at 444. This is in a white paper. I can give you my email address, and I can definitely send it out to you or send anybody the link. So it goes into the detail of the setup, the servers involved, etc. Improves CPU efficiency, right? I think one of the most telling things here, and it mimics exactly what Chris's slide showed. 16,000 mailboxes on one physical, this was done on a Dell physical box as well. Those 16,000 mailboxes on one host used less than 32% of the CPU resources on that physical box. Right? So this aligns with what Chris was saying in terms of Exchange not being CPU bound. So this is the 95th percentile send mail latency test, right? So what we came in at is 16,000 users came in at 184 milliseconds. Right? This is response time. You have to be under 500. So that 16,000 users, we easily came in with what Microsoft says we need to be in, as well as our 12, 8, and 4,000 users all came in less than 115 milliseconds correspondingly. In vSphere 5, we improved I call them the motions, right? vMotion versus and storage vMotion. As you can see, vMotion time in vSphere 5 was reduced by 34%. Right? And part of this is because now in vSphere 5 you can send vMotion traffic out multiple NICs. Right? That's one of the things that we improved in vSphere 5. Storage vMotion times migrated by 11%. Right? We improved the efficiency and the flexibility of the infrastructure. So we get a lot of questions on, is DAG supported? Right? As of Exchange 2010, right, you've always been able to run DAG mailboxes on vSphere. Microsoft said you couldn't vMotion or leverage any hypervisor high availability functionality. Translation, you could virtualize your mailbox servers, but you could not use HA or vMotion. Right? If you are running Exchange 2010 Service Pack 1, Microsoft will now support that. And that is a link to the public, at the bottom there, the public statement of that by Microsoft. Right? That is officially supported with 2010. And as Chris said, they were doing it even before it was officially supported. But we want to give you the official support statement from Microsoft. And in addition, there's a white paper there, a great white paper that we put out showing best practices around virtualizing DAG. right? And especially if you're going to be leveraging vMotion, there is a specific setting in that white paper in terms of delay that we will want you to set, right? We're basically taking it from 1,000 milliseconds to 2,000 milliseconds to ensure that it fails over properly. Recommended practices, right? Just do some really quick high-level best practices for you. With Exchange 2010, we'll tell you, even though Exchange is not CPU-bound, initially come out and roll out Exchange in a 1 virtual CPU to core ratio. Right? This is because if this is your first time virtualizing Exchange, as Chris said, this is an application that everybody touches in the company. It's the most critical, non-critical app in the company, right? Because when it's down, everybody knows about it, right? So Microsoft will also support a 2-to-1 CPU ratio. That's the maximum they'll support, but they will support an overcommit of 2-to-1 for Exchange. But be conservative when you initially roll it out. As you put it on the platform, right, especially if this is new, and you understand how it acts, how it reacts, then you can feel comfortable about moving other workloads on top of it and moving other workloads into it. So for the Exchange admins in the room, right, this is a loaded question. Right? You don't have to raise your hand or anything, but is Exchange 2010 is NUMA aware? Did I hear a no? That's correct. I don't know that I did, but we'll pretend. Right? Tom. Tom, is ESX NUMA aware? Okay. So here's something that we can do in a virtualized world that can't be done in a physical world, right? So meaning if your Exchange virtual machine can run inside the context of a NUMA node, for those that don't know what a NUMA node is, I've got my socket with my cores and memory local to it. And then I've got my next socket, cores, memory local to it, right? When you look at Exchange and TechNet, that's why they'll tell you. For the Mailbox role, it's 2 sockets, 6 cores, standalone Mailbox, that's the max, right? Because we have this thing called NUMA crosstalk. If we cross more than 2 NUMA nodes, the performance penalty is too great. So that's why Microsoft's very specific. And you can actually, as you track Exchange through the history of TechNet, you can see that this follows hardware, right? This recommendation by Microsoft. So, and another thing is, does Microsoft tell you to turn on hyperthreading or to turn off hyperthreading for Exchange? The answer is they want it off. What about VMware? Right? We tell you post-Nehalem chips, turn it on. We want it on. We can leverage that. And we actually do it a little bit differently than Windows or RHEL, right? So what do you do? As an Exchange admin, VMware is telling you to turn it on, and Microsoft's telling you to turn it off, right? So here's the reason why Microsoft tells you to do it. It can actually, there is a technical reason. You can back yourself in a performance problem. Because for those that size Exchange, when you size Exchange, you do it on the full context of what a core can do, right? A hyper-threaded portion of a core isn't the full context of a core. So if I'm running Exchange against hyper-threaded cores, Exchange isn't getting what I initially sized it for. So I get this hyper-threading conundrum. So how do I fix that? Well, one of the options is there's an advanced setting that you can set called hyper-thread sharing, and you put that to none. So I go in the BIOS of my server, I turn on hyper-threading, I go into my virtual machine on the advanced tab and pick this none option. Now when Exchange comes down, our kernel catches it, and you run against the full context of a core. Pretty cool. Memory, right? We will tell you to actually set a reservation for Exchange. Right? Now, I know Chris said that in their infrastructure, they don't need it. Right? They're running, they're fine. That's great. Our recommendation initially is to set a reservation for Exchange, protect the memory, don't let anything else come in and grab it. And I stress reservation and not limit. Funny story around this is we had a customer who we talked to about virtualizing Exchange. They got all excited. They went and did it, and they called us up and said, performance is terrible. This thing's horrible. We're seeing all this crazy disk I/O. We get on the phone, we look at it. We're looking at it. Microsoft's on the phone. They can't figure it out. They keep telling the customer, you got to go physical. You got to go physical. Well, guess what we found? a limit was set. So basically, Exchange booted, hit the limit, and then we at the hypervisor level started sending everything to swap, or to the page file. We literally unchecked the box, and we haven't heard from them since. So I don't know if it's because they're embarrassed or what, but so networking, we'll keep it pretty simple here. Use VMXNet3, right? Reason for that is that's optimized to run on the vSphere platform, lower CPU overhead, etc. One of the most important things from my section of the presentation, if you're going to walk away with anything, is this eager zero thick concept, right? If you're going to be running Exchange, and we will tell you, and our performance engineers will tell you, the performance difference between RDMs and eager zero thick VMDKs is negligible, right? Don't let that be your driving decision on if you go VMFS or RDMs. There are other things to consider, but don't let it be this. Real quick, high level, by default, a thick disk when you deploy it, right? VMware, when we come down, we come in and we write a 0 to that block, and then we write the data. VMDKs, and first time we only write to that disk. So if I got Exchange, which is coming down and writing a bunch of data in my logs in my database, and I got to write a 0 to that block before I write any data, there's going to be a performance hit, right? I can see all the wheels turning in the room right now, right? Eager zero thick, what that does is that goes and pre-zeros that VMDK for you. So what that means is now when I run this eager zero thick command, it goes eager zero thicks the VMDK out so that now when Exchange comes down and writes, everything's already been written to. I don't have that performance hit, right? So don't run out and do this to all of your VMs in the infrastructure, right? You only need to do this where it makes sense. High I/O, right? Your databases, right? And only do this in the SQL world, right? In the Exchange world, database, logs, transaction. You don't need to do it on your OS, right? Your OS isn't driving enough I/O for you to do this. Some real world stuff. Remember what this is doing when you kick this off? You're writing a bunch of zeros to the frame. Don't be building your Exchange servers and doing this in the middle of production, right? Because you're going to bring your frame down to crashing to its knees. And stand guy's going to come running out there going, "What did you do?" So, and the other thing, there's two ways to do it: VMKFS tools, and the other way is, and I know this makes a lot of sense, but when you're adding a VMDK, there's this option called make this fault tolerance compatible. What you do is if you check that box and click OK, what we'll do is we'll eager zero thick the disk in the background, but we won't enable fault tolerance for that VM. Okay? So there's two ways to do it. Some things, DRS host affinity. When Chris said the all eggs in one basket, one of the things to do is make sure you use these affinity rules. So if I got two CAS servers, I'm going to create an anti-affinity rule that says CAS1 should not sit on the same server as CAS2. And it's very important that I said should. Because in vSphere 4.1, you have should and must. And it's very important that you understand the difference between should and must. Right? If I got two CAS servers and 3 physical ESX hosts, and I lose one box and I've got the should rule, right? That CAS server will reboot on that, one of the other physical host. With the should rule in place, if I lose 2 physical boxes, now my CAS servers, as a last result, will both be on, but they'll both be on that last physical host. If I have that must rule in place, same scenario, that CAS server will not boot in that scenario, right? So this is why we want to make sure that we use the must versus should rule, that we use the should rule here. So I'm going to turn it back over to Chris so we can talk about 16 months of running Exchange 2010 in production.
Thank you, Jeff. So what we found, like we talked about before, we did successful failover tests, both with a DAG and with vMotion. vMotion within one data center, not across data centers, but DAG tests failing over across data centers. Our backups, since we moved to DPM, are running lights out. We have very few problems. In fact, if anything, we just need to check our LUNs every once in a while to make sure we have enough capacity for our backups as we add more users onto the platform. Very smooth. I think in the upcoming year, we're going to add another set of hosts to each data center. Exchange is one of those applications that kind of grows like a weed. You're always adding more mailboxes. I mean, unless you're an enterprise that has a really tight control over user provisioning and lifecycle, it seems you hire people, but the mailboxes never leave, or the users never leave. So for whatever reason, we're one of those environments. We're easy to provision users. It's the deprovisioning part that always kind of catches us. So we'll continue to add a little bit of capacity there and give us some more room for failing. And we continue to monitor and optimize. Like any enterprise, we migrate our people. That's great, but we need to continually look at the environment. How can we optimize it? How can we get more out of what we've got? Because I'm sure, like a lot of you guys out there, we're continually being asked to do more with less. So even though I want to buy another set of hosts in each data center, they might say no. Find a way to do it with what you've got. And so allowing the monitoring and the optimization continually allows you to do that. See where you can fit more things in. What can we do better? What can we do? Continuing pain points. So I would like to say we've been able to eliminate everything that causes us pain through the migration. A couple of things that we're still struggling with is service desk adoption. And this isn't really related to virtualization at all, but it's part of the migration. I thought I'd share it with you, is that Exchange 2010 brings a new way of doing things to a certain extent for your first and second level support people. So role-based administration, using different tools like the EMC or PowerShell. These are new skills that service desks and second level support need to get training on ahead of time. So you want to get out in front of that as quickly as possible. Get them and operations looped into the migration process as early on as you can so that they're familiar with everything and it's not just coming on the back end. Typically, depending on how long you've been in your previous environment, people are very set in their ways. They've done it this way for 2, 3, 4, 5 years, and it takes a little bit of time to retrain everybody. And then integration with legacy endpoints. And by this I mean things in your environment that are maybe old, that are certainly not going to be compatible with Exchange 2010 right out of the box, perhaps never. Fax connectors, like I said, network copiers, devices that you have out there that interact with SMTP or with mailboxes. They might use Exchange to do lookups to find people to mail items to, or if you're copying something on a network copier, to look up your email address, things of that nature. So just make sure you do, again, like I previously said, part of the due diligence, be very thorough, look at all that stuff in your entire ecosystem and get it all looked at ahead of time. Delivering value to the business. So everybody has this enterprise. IT is a cost center. You want to deliver as much value as you can back to the business. And Exchange 2010 and virtualization allow us to do some different things here. So, of course, we had savings in the data center. Those 102 physical servers that I mentioned, just about all of them were up for refresh. They're all 4 or 5 years old. There's some savings right there. Compared to 12 physical hosts, even though they're larger, big savings in hardware purchase. They're a capital expense that you could just check right off the list. And then data center savings from a footprint, power, cooling, rack space, all that kind of stuff. You're obviously freeing up a lot of that for use by other products, other applications, when you're able to consolidate like this. Simplifies accurate chargebacks. I can't tell you. So one of the things that the business always comes us with is you're charging us so much per user per mailbox as a centralized IT function. What's in that? How do you get to that price? And with a highly distributed, complex environment that's been around forever, it's very hard to go to each part of the business, because they bought these servers 5 years ago or they bought storage 5 years ago. How much did you pay for that? Boiling all that down into a charge per month per user per mailbox that you could accurately explain to them is very difficult. Some of those people aren't even around anymore. With this virtualized environment, it's very easy to say, because you have building blocks. This is what we paid for the host. This is what we paid for our storage. And if you want to figure in incremental labor and manpower and some other data center miscellaneous stuff, it's very easy to build pods or building blocks of servers, virtualized instances, and what you know what you pay for them, and then to charge back the business is much easier. Allows for greater flexibility. So, and this goes hand in hand with the next one. I kind of combine these two: quicker scale out or scale up. In a virtualized environment, obviously, you guys know this being at this conference, the flexibility this gives you over physicals. But from a business perspective, if you're a business that does a lot of acquisitions, for instance, you're buying up smaller companies and you have to quickly implement them or assimilate them into your environment. in a virtualized platform, being able to spin up a server in a day, to take on more mailboxes is great over a physical environment. A lot of times these acquisitions are held close to the vest. You don't know about them. You don't have a lot of lead time. You certainly didn't budget for them. So being able to spin up new servers, you've got a gold master, a template that you make of each role, your cast servers, your hub servers, your mailbox servers, spin one off. Provision a new server, and you've instantly got capacity in most cases to add new mailboxes, to add new users. Lower administrative overhead. Obviously, going from decentralized to centralized really lowers your administrative overhead, but going to a virtualized environment does too, and it allows the Exchange administrator to focus on Exchange, okay? There's other teams taking care of your storage, taking care of your virtualization, and the Exchange team can focus on that. A lot of times in a physical environment, you're doing multiple things at once because you're managing your servers and, connections to the network, data center, things of that nature. This really delineates everything and lets people focus on where their expertise is, but allows you to have less of those people. Take the extra staff you've got, turn them over, and have them do things that add more value to your business. And finally, more options in a disaster recovery scenario. So again, with vMotion, with high availability, you've got a lot more flexibility in the way you recover Exchange. On top of that, with the database availability groups, it makes disaster recovery a lot less of a pain point than it was under 2003 or in a physical environment. You can bring things out much faster, shift workloads, move them over to other data centers. So with Exchange 2010, once you're on that platform, you don't have to take a mailbox down to migrate it. You can do a live migration, and the user is still up through the entire migration. And it allows you to do patching. You can do host-level patching, move your virtuals over to another host, bring it down, patch it. Downtime is a lot less, too. Just some background information, email, Twitter, if you have any questions.
Shameless plug for our blogs.
Yeah, exactly. Jeff loves questions and emails. I do too. So, if you have any questions after the conference is over.
Yeah.
Do you use 10 gig networking? And if so, what is your utilization rate on them? Or what is your utilization rate on your 1 gig mix?
Yeah. So we do not use 10 gig networking. We're 1 gig. On the mailbox, or the host, we did ether channel bonding to allow us to get more throughput. I don't know what the utilization is, but I'd be happy to get that for you.
Okay. Has it come up as an issue?
No, absolutely not.
Yeah.
What's been your experience virtualizing the unified messaging role for Exchange?
So we do not use unified messaging, unfortunately, so that's something I can't speak to. Microsoft, I believe with Service Pack 1, finally approved it for virtualization.
As of Exchange 2010 Service Pack 1,
right.
It is approved and
Right.
supported by Microsoft on a SVVP platform, which ESX is.
Right.
This gentleman here had a question in terms of transaction logs generated.
Right. So he asked, what's our average transaction logs per mailbox server? So just for the crowd, that's highly dependent on traffic, users, and all that. But we generate roughly, I want to say, around 5,000 transaction logs. Cache mode. So we've specified cache mode for all of our clients, absolutely.
One of the standing mics back there.
Hi there. Yeah, I noticed you're not using VMDKs for your DB and log files. You're using RDMs for that.
Correct.
Is there any particular reason? Because surely you're missing out on stuff like storage I/O control by getting them the RDM reads.
I didn't hear the last
Storage I/O
part
control or...
Yeah, surely you're missing out on a number of sort of very handy features like storage I/O control by using RDMs. So what sort of influenced that decision?
There wasn't one set of ways to go. So we kind of looked at the pros and cons from the best practices of VMware. Use RDMs if you're clustering, things of that nature. We decided to go with that, though, because for us they were a lot easier to move around and provision from a storage standpoint. There wasn't one unifying reason that we chose one over the other, though.
Are you using?
Yes.
When
you scale down from 102 servers to 12, was it the same kind of servers you had, or was it multiple types of servers? And also, what was your largest mailbox size?
Mm-hmm. So the servers that we had out in the population were HP, G4s, G3s, G5s. And we went to Dell R910s. So the hosts were obviously much larger to support the virtualized capacity. Largest mailbox sizes, so that's a good question. Across our business units, because we're kind of inheriting this Exchange environment that was previously managed by the business units, some of the businesses were very strict on their mailbox sizes. So their quotas were literally 40 megabytes for a normal user. Executives got like 100 megabytes, but they were very tight on their controls. And then we've got other business units that went 2 gigabyte, 3 gigabyte mailboxes. We were up to even some 5 gigabyte mailboxes. So we had the whole range, to be honest. Yeah.
Did you consider not building your own servers but leasing them in some kind of a CaaS or SaaS model?
As in outsourcing them?
Yeah.
We did. We did about a year and a half study on outsourcing, and unfortunately, it came out in favor of outsourcing. Email's a commodity function. It's very easy for people to do. In the end, we were hampered by legal restrictions that we could not outsource our email, is what it came down to. So we had to look at...
legal business.
Yeah. Well, yeah, the legal of the company. Compliance and legal issues stopped us.
Are you using public folders?
We are.
How are you handling backup with that for DPM? Because DPM doesn't do, you have to recover the entire public folder structure.
Right. So we do traditional backup for the public folders. We use Windows backup. But the biggest way you want to back up your public folders is just have more than one replica. So as opposed to trying to have to do a whole restore, if I've got replicas in multiple locations, I can then recover the data, and that's a much better strategy.
What's your average database size?
I'm sorry, what was that?
Average database size?
Our average database size right now is around 250 gigabytes.
Go ahead.
There was a quick line item on there where you said multiple para-virtualized SCSI drivers.
Yeah.
And I was wondering, did you test that to see where you found like that trade-off? Where was that driving decision to go to with that?
So that's a VMware best practice recommendation. I don't know if did you implement that at Reed?
I'm sorry, I wasn't listening.
The multiple SCSI adapters inside a virtual machine.
No.
So the reason we recommend that, right, is if you think about...
Wait. I'm sorry, you're talking about, for all my RDMs, putting about multiple SCSI? Yes, we did do that.
Okay. And so the reason behind that, and the reason we recommend that, is inside Windows, if you think of a physical box, like I got 2 HBAs, that's 2 queues inside Windows that I can generate I/O with, right? Inside a virtual machine, this is your VCP4 test question, I can do 4 SCSI adapters. That gives me 4 queues inside Windows in which I can get a bunch of I/O queued up, and now I can get a lot more I/O on the wire, right? So basically what we can do is 1 SCSI adapter for OS and binaries, another one for logs, another one for databases, another one for backups, another one for insert your option below, right? And so now, and the reason we recommend the PV SCSI, and the recommendation is different between 4 and 4.1, there's a KB article in there that we talk about it, but it does use it uses less overhead on this physical host CPU. So it's going to be lighter on your physical host, and also it'll push more I/O out. So,
before the next question, quickly, please remember to fill out your surveys. Give us your feedback. We appreciate it.
Are you using any enterprise vaulting or any archiving of your email?
So previously, one business unit deployed Enterprise Vault. We're moving away from that right now. We're looking at implementing a business-wide archiving standard. We have not put it in place yet, though.
Did you ever consider Veeam or like vRanger for your backups instead of, the Microsoft version?
No, and part of that was because we've got like any other large enterprise, we've got a team dedicated to doing backups, and they've got their tool set that they like to use. So it'd be very difficult to introduce a new tool set. They'd be very hesitant to that. So we found one that was low overhead, easy to use, that operations could adopt. And then for those backups that we have to take off disk for like litigation reasons or whatever, then they use their tool to suck it off of there and pop it into their VTO.